Good morning, good afternoon, good evening, whatever it might be, wherever you are. Nice to be back, I guess, in a little bit of a different capacity. We're going to try this out again. Because recently, of course, I don't work at Microsoft anymore. That was part of the big layoffs from a few weeks ago. So no more 45 show streaming for me, which is kind of a bummer, but, it's okay. But I figured, well, I might as well give it a shot here. Share some interesting stuff, since I don't really know what I'm going to do exactly just yet in terms of jobs and stuff like that. So I figured, if nothing else, I'll take some time, figure out some things about myself. But more importantly, for a long time I used this DarkSky API, and yesterday I was using it for something really stupid. I mean, this isn't anything exciting. It was literally to show the weather in my terminal, right? So this is nothing like outrageous. But yesterday I noticed my terminal was blowing up saying, oh, they can't parse this data because it's getting bad data from the API. And of course, I went and looked, and DarkSky was bought by Apple. And they shut off the API. And it was a pretty good API. I liked it because it was easy to use, but it used an API key. Pretty basic, pretty straightforward. Put an API key header, and away we go, right? So I started looking into it, and thought, oh, well, I'll just go migrate this over to WeatherKit, no sweat, because WeatherKit gets you some free stuff and whatever. You get like 500,000 calls or something crazy like that a month for maybe 50,000, I don't remember. You get so many, far more than I'll ever use for free if you're part of the Apple dev program or whatever. So I thought, sure, like no sweat, we'll go take a look. And then I realized, and this is what was fascinating, is we used an API key to talk to DarkSky, right? The authorization header for the WeatherKit REST API is an elliptic curve 256-bit key signed JWT, which seems like a pretty big jump, especially if you're doing it like in Bash or anything like I was doing. I was doing it in CSH, and so I thought, well, let's make that happen. I'm not the only person who's had to deal with this. And so while I may not be the first, I figured, hey, what's the problem? Why don't we, let's go take a look and show how this works and take a look at it. So yeah, that's what I'm doing. So anyway, thanks for joining me today. Nice to see some folks here. So today we're gonna go sign some JWTs with .NET, so that we can call and get weather, because those two things feel completely similar to each other. Obviously, like this is such a high security API that we need to go and do this, but that's okay. So let's go. I guess we're gonna take a look at it. So hope everybody's been well. By the way, it feels like it's been a long time since the last saw anybody, because this has been going on for. Decided to take some time after getting laid off. It's kind of a weird feeling to get laid off, because you get laid off with a bunch of your friends, a bunch of people you know, which I guess is a good thing, because at least they're people that you know. But there are definitely parts of it where you're kind of like, not quite sure I like that. Like, not really sure what I'm going to do from here. And lots of questions in my mind, like, do I even stay in software anymore? Like, or is there something else? I don't know. There's something I've been thinking about is, how long does this continue? Chasing the software dragon, or do I go find something else to do? But I don't know. Maybe that's just an old man talking, because I'm middle-aged now and don't know what I'm going to do with myself. So anyway, enough about me. Let's go take a look at some of this code here. So let's see here. If we take our wait a minute. I hope all of you can hear me. I feel like I just lost my microphone. I'm not entirely sure why. I hope all of you can still hear me though. Let me know if you can't, or if you can, or if you cannot. I guess I could always check on my own. But okay. So let's take a look at this WeatherKit REST API. So the DarkSky API was really good, but sadly is gone. So we have to move over to WeatherKit. I was using REST API, so no big deal. Thanks for following, by the way. Greenest to Josh. I still have to get like all of the stuff set up for people sign up or people follow and join. Like I kind of forgot all of the kind of forgot all the work that goes into like building layouts and all that sort of stuff. Like It's definitely different when you have to do it on your own with your own dollars. So let's take a look at this WeatherKit REST API. The API itself is fairly straightforward. We're going to call API v1 weather. We're going to pass it a Latin along into the language, and we're going to get back. There are various data sets that you can get. So there's data sets like current weather. You can get historic weather. You can get forecasted weather. Lots of different things you can do. For me, I literally just want. I literally just need the current temperature. In fact, I don't have it on this terminal, but I will. Let's pull up the. I'm going to pull up my P10K. Whatever. I was using the Powerline 10K ZSH thing, right? So, one of the things I noticed. So, like when I was first getting my terminal all snazzy. Everybody was using Powerline 10K, and so that's what I used, which is fine. Like I think it's cool. Would I continue to use it? Not entirely sure, but whatever. So I still have it on my WSL box on Windows, and I use it on an old Kali Linux box that sits here and runs. And so I thought, now it's blowing up my terminal. Let's go take a look. So in here, there's a P10K, or there should be. I guess I have to do an LA. So this P10K, let's open that one, okay? So, like, we'll just do a code window here. Probably a roundabout way to do this, but whatever. And if we look in here, there's a bunch of goop, right, which is what it is. But down here, and like a lot of this, of course, most of this was written, most of this is part of the Powerline thing, power level, whatever it's called. But there is one in here called DarkSky. And this was one that I had written specifically so that I could get the weather in my thing. And you see, it's pretty straightforward. I got my coordinates, although I don't even know if these coordinates are accurate anymore because I've moved. Our DarkSky API key, which is basically all it was, and then a local cache. So I could cache it because I didn't want to like constantly beat this API up. So I thought, I'll just cache it in this little file. The temperature isn't going to change that much, especially not in 900 seconds, which 900 seconds seems like an oddly specific amount of time. And I have no idea why I chose 900. Maybe it's because the 9 and the 6 on a keypad. But so what's 900 minutes? 10 minutes would be, or 600 seconds would be 10 minutes. And then another 300, it's 15 minutes. Okay, so 15 minutes, well, not going to change too much. So there's also some weirdness with like date formatting, of course, imagine that. But at the end of the day, it's a simple curl to call the old DarkSky API with a forecast, get with some coordinates, and then I was excluding basically everything because I didn't need any of it. And then we get this, and then write it out to the cache, and then every time the console would run, we'd get a temperature on the thing, right? Pretty straightforward thing. Put a little symbol there, like make it a different color depending on how hot it is. But the API call itself was really, really straightforward. It just used our API key and away we went. You could put the API key in an environment variable or in some other like in file. Like I didn't really care that much, but I never checked these things into anywhere, which I should probably do. You'll notice the .back, .old, all this sort of silliness that you do when you don't check things in. But anyway, if we try to run this today, it just blows up, and then JQs are like, "Oh, there's no data for me to parse because there's not enough error handling in here," and then it just ends up makes the whole terminal just kind of a big mess. So instead, we're going to have to go down the route of signing this JWT and using that in the header. So the first place for us to start is let's go look at request authentication. So this is the doc for how this works. And I went and took a look at this yesterday. And I have never in my life, and I'm no iOS developer, so, like, well, I'll preface it to say that. I have never in my life understood how this services IDs and app IDs and certificates and like identifiers, I've never really understood all that in the whole Apple dev portal thing. I've just never gotten it. It feels like there's so much there, and it's almost as if the data was taken and made as confusing and complex as possible. Like, I have no idea why it has to be the way it is. Like, what's the difference between a service ID and an app ID, for example? And like, when we generate a key, the key isn't actually linked to anything. So it's a key that we have to go download. So it's a certificate, or, it's a key data. but it's not like linked to a service. So the only way we link it to the service is through the name, is through the identifier. Like, it just seems like a strange collection of things, but whatever, no judgment, right? It wasn't my service to write. So we need two things, okay? So you go to your dev portal, you get signed in, and we're gonna have to do two things. First thing, we have to generate a key, okay? And when we get this key, I downloaded this one yesterday, two important pieces of information. You can only download it once, so once you generate it, that's it. Copy this key ID, because you will need it. Because we're gonna actually, in the JWT that we send up to the service, we're gonna have to have this key ID, so you don't wanna lose it. So we got the key ID. And then, of course, you'll have the P8 file or the PIM file that you download that actually has the certificate data in it, okay? So you get your key from here, and then you'll go over, and this is where it starts to get like confusing for me. So there's services, but that's actually not where we need to be. We need to go to identifiers, okay? And you'll notice there are app IDs, and then there are all these other types of IDs. So then there's a services ID, and here's where we'll create the service identifier that's going to use the thing, right? So if we were to create a new one, we create a services ID, right? There are lots of other ones for other things. Some of these seem self-explanatory. They seem to get more self-explanatory, maybe the newer they are. And then we give it an ID. So the description is whatever. The description here is whatever. Like, I preface mine with dev.jpda, since that's like sort of my namespace. And then, a service name. I already created one, and I named it, I named the one I created terminal weather, because that's, I guess, what it is at the end of the day. And we'll create this, continue, and then we'll register it, okay? So once we register it, it has a name. And that's really it. Like, the identifier is about the only thing we really get from here. We can do things like sign in with Apple, but we're not signing in, really, at least not yet. We could do that. It might actually be kind of cool. And we'll get back to that in a minute. But ultimately, at the end of the day, it's just a string name, right? So this is our name, terminal-weather, okay? And so we've got our identifier here, we've got our service ID, and we've got our P8 file, our PIM file that we downloaded earlier, which in my case is right here, this auth key, and then of course it has the name after it. So I know that's small, but just believe me when I downloaded my key, because you can only download it once. So that's got our private key data in it, okay? So these are the two things we got to do in your Apple developer account. If you don't have an Apple developer account, I think there are ways to get them like free or cheap if you're a student or like work for a nonprofit or something, but otherwise it's like $100 a year or something like that. I'm not entirely sure. So we get our private key and our service ID. So we got those, which is great. And then we have to go and generate our token, okay? Now, we're talking about private keys signing tokens here, right? This isn't like a symmetric key or something. And so I think in a lot of cases, at least for me, it kind of took me off guard. And I do identity stuff and have for a long time. And so I felt like if it took me off guard, then maybe it took somebody else off guard and they just went and got a new API. But ultimately, we've got these JWTs that we need to construct, and then we need to sign them. And we're going to sign them with the key that we just downloaded. So that key that we got will be our signing key for this. And we've got some basic stuff in the header, the algorithm. It's ES256, which is the elliptic curve 256. We've got our key ID, and the key ID is the key ID that we get from here in our keys. So our key ID is this here, right? So in your key ID or in your key list, the list of certificates, this key ID has to be in the kid part of the header, and then an ID will be the team ID, and then the service IDs. The team ID is your Apple team ID, like the Apple, like in my case, it's this one that's up here in the corner, this 6RT85, whatever. I imagine there's somewhere else you can get it that might be easier to read than this. I'm not entirely sure, but you can definitely get it from here. And then it might be in like the My Account page if you can get there. It'll be somewhere in here. You'll have your team ID. Seems kind of silly. There it is. There's your team ID, right? So you got your team ID. I need to update my address. Got your team ID, so you're gonna need this value too, and you get another 10-digit identifier, right? So we've got our team ID, we've got our app ID, which is our dev.jpda.weather-terminal, and we've got our key ID. And those are our three big bits of information we're going to need in addition to the key itself. Okay. Then in the payload of the JWT, pretty standard set here. We've got the we have the issuer. So this is the thing that issued the token. Isn't maybe entirely like sort of accurate in this case, but that is our team ID. So you can kind of say like, oh, I guess you are issuing your own team ID. Like your team is signing this cert because it's part of your thing. Maybe, I don't know. But the issuer is your team ID. Then you've got your issued at and expiration times. These are just normal epochs. And the subject is just our app ID. That's it. This was at first a little like surprisingly difficult to get everything to work exactly right, because what I found is a lot of the values in here really are like quite specific and must be very sort of specifically done. What's interesting is down here at the bottom, it's like, oh, by the way, like, hey, you got a private key and these tokens, like you can't share your private key, so you can't ship that in an app, obviously, but you don't want a super, super long-term token length because then somebody could swipe your token and go and use it. I remember back when Apple ID, sign in with Apple ID or whatever first came around, that was one of the big things in B2C was, or in Azure AD B2C was, go create a 6-month, 6-month expiration JWT to use as the secret for your thing. And 6 months was chosen because it was the longest that you could make it, and have Apple still recognize it as valid. And of course, that's probably not really a great user experience by any definition, either having a 6-month expiring token or having to go and generate new tokens on a fairly frequent basis. So for me, this got me thinking like, well, how are we going to generate these tokens in a way that my terminal can get them when it needs to? So I'd like for it to stay relatively local to network. I mean, it can live on something else. And I guess maybe put it on the internet, do like a function, like a lambda or a function on the internet. But then it's a question of, okay, well, if I'm going to do a lambda or a function on the internet, I don't necessarily want everybody going and using my Apple account to go get weather data, because they'll burn up all my tokens, right? Or burn up all of my calls. So then it's a question of, well, then we got to authenticate to our function. And how are we going to authenticate to whatever our function API, like whatever that's going to be? So I haven't really thought that one all the way through yet, but whatever. So I'm going to go over to Postman first so we can at least get an idea. Amazingly, and this blew me away, and in a good way, I guess. Amazingly, Postman has support for, in the JWT bearer, authentication type or authorization type. So when you create a new collection or when you create a new request, there's an authorization sort of configuration. In here, Postman has all of the pieces required to go and do that, to go and sign a JWT with a specific algorithm with data that we can go and put in, right? So it's kind of cool. So we select our file, that's got our private key. I love that even when you select it, it still puts the vast majority of it down here, and you can't make that smaller, but whatever. So then we have our payload, right? So in our payload, we need our issuer, so this is our team ID, right? Issued at's our timestamp of now. Expiration is going to be our expiration timestamp, and we'll go look at how those are generated. And then our subject, which is essentially the subject of the token, the thing that this token is identifying, is our weather app, dev.jpda.terminalweather. Now, Postman will go through all the headache of, not headache, I guess, of injecting the right algorithm type into the header. So fortunately, we don't have to do that. But in our headers, we're still going to have our KID, right? Our key ID. And this is the key ID that we needed that identifies the key, not the team and not the application or anything like that. This identifies the specific key ID. And then we have the ID, which is our team ID, sort of prepending our application or service ID. So in this case, it's just my team ID, 6RT85M, blah, blah, blah. With a period, and then the rest of like my namespace and then the app name, the service ID. So when we do this, these get generated and stuffed into the authorization header straight up. So let's look at this. We'll look at the payload really quickly. There's a timestamp, and we notice by using the dollar here with the curly braces, this is a Postman variable. So this is pretty cool. It's just a timestamp. It's already correctly formatted, amazingly enough. The expiration timestamp, though, is not. So we have to use here, we have to use what's called a pre-request. Is it a pre-request script? Wait a minute. Where's my pre-request script? I have to go back and look now. I thought for sure this was here, but maybe I must have done it somewhere else. So let me go, I guess we'll just go pull this one up instead. Here's our pre-request script. I put it in the wrong place. So here's our first call to weatherkit.apple.com. So this is our straight up API call. And then here is the pre-request script. Now the pre-request script should really go in the other one. So I'm going to move that now that we're sitting here, and then we can take a look at it. So in our pre-request script, this is where we're going to handle generating that. So the first thing we need to do is get right now. And apparently whenever you're using the global sort of, I don't think they're actually called variables, but they're like these global, like sort of system variables, for lack of a better term, like timestamp. In order to use those, we have to use this replace in, okay? So we get our timestamp value and then we multiply it by 1, because while it's a number, this is JavaScript, and so it wasn't actually typed as a number. And so I ended up with now 3600. So we're going to add some time to this. We're going to add in seconds. We're going to add an hour's worth of seconds to the end. And then we're going to set a collection variable called expiration timestamp. So by setting this variable, now we have our issued at time, which is current timestamp, and then we'll also have our expiration timestamp, which is our time that this is not going to be valid. And I'm console logging both of them. We don't have to do that anymore either. So let's save this. And so this is going to run on everything that we get. So the first call that they say you should make, the first one that you're really supposed to make, let's see if I can get this out of the way, is called availability. And this will tell you what is available for your thing, right? So we send this, you notice we get current weather forecasts, daily, hourly, next hour, and our weather alerts. So these are all the types of data sets that are available for the lat long that I have. And the lat long I have is my home lat long. They're just Postman variables. If we look at the headers and we look at the ones that are sent, let's go take a look at this token. Now this is the token that Postman generated for us, right? So if we go here and put this into like a jwt.io, let's go see what is in this header, or what is in this JWT, right? So we look in here. Maybe I didn't copy it. Let's see. So we get this. We'll go put it over here. I don't know why my paste doesn't seem to want to work. There we go. Get rid of the word bearer. And now we see this is what Postman generated for us. We've got a kid. That's our key ID. We've got our ID that's correct. Our issuer is correct. Our issued at time is a valid time. So Thursday, April 20th at 11:27 GMT minus 4, which is me, which is where I am now. So that was just a little bit over a minute ago. And it will expire at 16:08. So my math is wrong on the number of seconds, I guess. Number of seconds under an hour, but whatever. It will expire. Wait a minute. It expires yesterday? That doesn't make any sense. It expired yesterday, Wednesday, April 19th. I don't understand how this works. I have to go back and look at my math. Apparently my math must have been wrong somewhere. Or maybe just the way that, oh no, 1682, 1681. So it's interesting that this is even considered valid, but whatever. So our issued at time is today, just a little bit ago, and our expiration time apparently doesn't seem to matter because it's registering as yesterday, which I don't fully understand. Oddly enough, our call succeeded. So I wonder if actually my guess is that it may be that because we've updated it, it probably got updated when the pre-request script ran. It most likely got updated, but even then, that would imply that what this thing is saying that it sent didn't actually send that token. It sent a different one, which is even more sort of fascinating in its own regard, I suppose. So the value of this header is tentative. You can find the exact value in the console once the request is sent. So, interesting. I did not realize that was how these things treated them. So that's okay, because we can go look at the call that we just made. And in here, we can look at our token. Let's go grab our token, and we'll take this one over to jwt.io and see what it says here. Apparently my keyboard doesn't work in my browser anymore. Okay, a little strange, but here's our new one. So this one has an issued at time of 11/27/53, which is a couple minutes ago, and an expiration time of 12/27/53. Okay, good. I was starting to lose my mind there a little bit. Like, is my math wrong? And it's yesterday? Like, doesn't make any sense. Okay, good. So we know our token's good, and obviously it is because the WeatherKit API is accepting our request. So because these are our available data sets, in our next call, we just have to say which data set we want. The data set I want is current weather. So let's go look at this. This request, very similar. We're going to add a language. This is just your country code for language. Not country code, language, the ISO language code. For me, it's English, so that's EN. And then our home latitude, longitude, same way that, same ones you'd used before. And we add a query string parameter of current weather for data sets. And we have to send country. And from here, we now get some JSON. And it looks like my current weather is 80% clouds. I guess that might be pretty good. And then our temperature is 13.26 Cs. I don't know how many Cs there are in an F, or how many Fs there are in a C. Is this one, for the Cs, it's 9/5, is that right? C times 9/5, which is almost 2, which would mean, 9/5 plus 32, right? Isn't that what C to F is? So a 13.26. What is up with my keyboard today? I just don't get it. 13.26 C to Fs. That gives us 55.86 Fahrenheit Fs. And if I take a look at the current weather on my phone, which presumably this all comes from the same place, right? This says it's 56, right? So 56, then it looks like we're good. Although they're doing a little bit of rounding. I'm not entirely sure how much I like that rounding, but it's okay. If I do the weather app on here, it doesn't take me where we go. Okay, so anyway, so this is, luckily, we've got our data right here. This is great. Now, I haven't found a good way to trim this data set back. I wouldn't necessarily really want to pull all of this data every single time because it's kind of a lot. Like, I don't need cloud cover. Like, maybe I'd get condition. Maybe I'd get temperature, or maybe temperature apparent, which is like a wind chill or a heat index. There's some other interesting bits in here like UV index, etc. But the ones I really would need for my purposes are relatively minor. But such is life. Everything is sent in metric units, and so it's on you to go and convert them. That's like, according to the API docs, that's what they say. So we know what we have to do to go and make these calls, but I can't run them from Postman all the time, right? So let's figure out a way that we can do this with .NET. I mean, why not? I mean, .NET, I guess, the Swiss Army knife of other things. So let's do. Let's get my terminal up here. Let's go create a quick. So .NET there's lots of different libraries for doing this. Okay, so we've got. In fact, jwt.io has a list of them, right? So in here, there's a whole list of JWT libraries. And I don't know why .NET's at the top, but it is. Maybe it just knows who we are. But these are all libraries for writing tokens and doing whatever, okay? So, of course, Microsoft has theirs, which is System Identity Model Tokens, JWT. If you've been in like the ASP.NET world or in .NET world for a while, you may have used this library directly. A lot of it depends on what kind of implementations you've been using. Another one is JWT.NET. I've actually never used JWT.NET, but it looks kind of neat. So let's start with identity model tokens, and then we'll go over to JWT.NET, and we'll see which one we like more. The reason I say this is, if there's anything I've learned from working with lots and lots of customers for so long. Hey, Nick, thanks for joining, buddy. Good to see you, too. I haven't seen you in a while. if there's anything I've learned from working with lots of customers for a long time, it's that getting approval to use libraries that either that are of unknown provenance or that are open source or whatever, in big enterprises can be in some cases quite a headache. And so that's why, even though excuse me, even though certain implementations like open source implementations may be significantly better, easier, faster, stronger, whatever, there are still lots of enterprises that say, nah, like you got to use what comes out of the box or what comes from vendors ABC. And so, of course, if you've lived in the .NET ecosystem very long, you know there's a lot of that lives in .NET. And so there are lots of implementations in .NET of different things that some people may really like and some people may really not like, but that may be all they're able to use. So since we're here, we might as well let's use both, right? Why not both? I need like a little meme button so I can make memes come up. So anyway, let's start with system identity model tokens. I'm just going to start with a little console app here. So let's do a new one, and we'll call this WeatherKit JWT generator. And we'll do a .NET new console app. And let that do its thing. We'll do a .NET new git ignore, just so we don't have to deal with all that silliness, because of course we'll put this up in GitHub afterward. And then we'll open this up in code, VS Code. So I use VS Code personally. I like it a lot. It's kind of my go-to for doing any kind of coding now. That may be because, that may be because because that's just the kind of stuff that I'm working on these days, but whatever, at any rate. We've got our code here. Let's get our window. What's going on with my computer today? Not really a fan of this, to be perfectly honest. I can't seem to click anything. There we go. So we got our VS Code here. And we've got to do a few things. So we got our terminal. We're gonna so first we need to add the package for system identity model tokens JWT. So this is system identity model. Most of that code is out on GitHub now. It's a .NET 6, .NET Standard. So it's if you're stuck in the .NET only world, there's a sort of a native implementation. I will say that it is not obvious on the surface how to use it. I may not actually be even using it correctly, to be perfectly honest. But the fastest way to learn the correct way of doing something is to do it the wrong way on the internet. If I've learned anything, it's that. Okay, so we've got our system identity model, JWT, which is great. And I think that's going to be the only library we actually need is going to be that one. So let's get into our code. Now, I'm going to sound like an old man here. I do not like the whole small, minimal API thing because I feel like I have no idea what to do. It's too clean slate. It's too open. And I feel like there's all this magic that's happening behind the scenes. And magic just, to me, I guess, and again, I'm an old man. Magic to me just feels like something that will break that I won't understand later. But whatever. That maybe the entirety of software development is predicated on magic anyway. I don't know how bits get shifted in a CPU register either, so maybe it's better that we keep things abstracted. Anyway, enough about that. So the first thing we got to do is we got to build our JWT, right? And so in order to build the JWT, there's some structures we can use. In fact, what I could do is let's see what Copilot says. Let's see, build a JWT token. Cool. Let's see if it gives me anything. Anything, Copilot? It's cranking. It's cooking in the corner. You can see it down here spinning. Are you going to give me one of these? Oh, no, it didn't give me anything. Is it because I ATM machined JWT? No, doesn't seem to like it. That's a bummer. I thought for sure it was going to give me something. That's okay. I don't want to disable Copilot, though. So let's see. Let's start with... So the first thing we need to do is we need our JWT header. So let's call this our header, which is a new JWT header. Okay. And this is all in system.security.identity model. So, of course, that's not here. So we're going to we add a using for system identity model tokens JWT. That's the thing. That just feels weird to just write it right there, like straight up. it just seems a little, I don't know, it just feels a little odd, we'll say. Okay? So we got our header, and in our header, we're going to have to give it some information. So the first thing we're going to do is signing credentials. That's correct. However, our signing credentials, like you'll notice that this thing's like, oh, you should use a symmetric security key. Well, we're actually not using a symmetric security key because we're using a private key. So our private key is going to sign it, and that means that by signing that, we're not actually sending the key. So a symmetric key is like just like a long string, like a secret or some bytes. Much easier to deal with in terms of like knowing what they are and manipulating them and managing them. But you have to send a secret over the wire. And that's like the big risk. You don't necessarily want to send a secret over the wire if you don't have to. With the private keys, you sign a thing and you send the signed thing over the wire. And that just means that anything can go and verify it if it has a public key. That's ultimately what we end up with. So we're going to need signing credentials, but the signing credentials we're going to use are not going to be symmetric keys. They're going to be asymmetric keys, which means we got to go create our key actually before we do this. So, and here, I'm just going to call this key, and then our the Apple doc's pretty clear to say, like, you must do this, right? So, ATM machine, yeah, like, I kind of like that one too. I thought it was a good one. It's sort of a, I don't know. It's amazing. Like AI is so amazing in what it can do. Of course, we hear about ChatGPT and GPT-4 and all sorts of stuff all the time. It's amazing in what it can do, but then at the same time, it's like it can be foiled by JSON Web Token. So, and then in here we need ES256, which is what Apple requires. That's ECDSA 256, 256 byte hash. So, we actually have a thing we can use here. We don't have to use a string like a barbarian. We could use security algorithms, and this is ECDSA 256. There we go. And this requires a using, and this is in the Microsoft Identity Model Tokens namespace. Interestingly enough, this is in the Microsoft Identity Model namespace, not the System Identity Model namespace. Just remember that for the future. Okay, so we got our 256, which is great. And then in our header, there are two fields. Remember, there are two fields that we have to worry about. Now we're going to come back to our key here in a minute because we obviously don't have a key, but let's get the rest of our stuff in here. So Copilot is going to give us this, which is great. And so we have our KID. Now our KID, if you remember, this is our Apple key ID, which we can come here and get. And we'll have to go and paste that from somewhere else. So we have our Apple key ID. And then we will have, then we have the ID, and the ID is going to be the team ID. It is the team ID dot app or service ID. And then our KID here is our key ID. Okay, so we've got those two. I don't know what this thing's complaining about. Let's see, string object to string. I guess it wouldn't be a string object, it would be a string. Yeah, there we go. Don't know why it told me that. So we got our key ID, we got our ID. Let me go get these IDs. So we got our key ID, I got to sit over here. Here's our key ID. In fact, let's just do this. We should probably put these in configuration, which we should do when we get to, I think what we should do when we get to time to put this in like an Azure function or something, right? So I'll just keep this simple for the moment. We can do consts. We can do our private. I can't do these here. Const string, and then you're supposed to do them in all caps if they're constants, right? Or again, I am aging myself. That's okay. And then our, let's see, our service ID is dev jpda terminal weather. Our key ID, I actually put the key ID up there wrong. The key ID is this one. We'll just change this one to key ID. We'll change this one to team ID. And our team ID is this. We get my team ID from over here. Team ID goes here. Cool. And then our last one is the concatenated team ID, service ID. That goes in our header here. So for our kid, we put our key ID in here. For this, I guess we'll just do the concatenation here because we don't need that ID anywhere else. So here we'll do team ID dot service ID, and of course I need my quotes. I think I'd never written software before. Our team ID, and we have our service ID, okay? Why is this blue? Main creates a new instance of JW. Oh, okay, yeah, we'll use it. We'll get to it. Just, you got to give us a little. You got to give me a little bit of time. It's very impatient. Okay. So we have our header. Now that we're referencing tokens, we can get rid of this. And we need a key, though. So let's get our key. And, oh. Let's see if what Copilot is suggesting is something we can take. Okay, so we have a new key. However, we need to provide it with our key data, right? Because we have a key, which is the key that we downloaded. So we will create our key, and then we will, let's see, in here, I believe we should be able to import these from a PIM file. Oh no, we have to do that. So we start with our ECDSA here. Okay, oops. So we start with our ECDSA. But we don't want to generate a new one. So before we wrap the key, we need to create, that's what I mean. Like, I always get confused. So this creates this here, and then our cert cred, I believe, on here is where we can import. We can import from our PIM. Okay. So in here, we're gonna have to go get our PIM here in just a sec. That's not gonna be the file name. I'm just gonna copy this into the tree for the moment. Not really what we should do. Oh no, my private key's on the internet. That's okay. We'll go generate a new one after this anyway. And in here, we'll call this, let's see, this is auth key PM blah, 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 .p8. Okay. So now we are referencing our files. This is the file we downloaded earlier from the developer portal, right? This is what we downloaded earlier. So this will import that in from the PIM, okay? And then we're going to create a key from we're going to create a security key, an ECDSA security key from the ECDSA, I guess, algorithm wrapper that has our PIM data in it. Okay, so we got this. So now we have our key, which is great, and from here it's kind of smooth sailing. So we've got our new JWT header. Let's see, why is this whining? What is the problem here? What did I forget? Anyway, so we have our header, and then we got to go build up our payload. This will be a new JWT payload. And this, we can either send in a bunch of things, which is kind of silly. I think we should just send in an IEnumerable of claims. And it looks like what Copilot's offering us might be pretty good, actually. The issuer is a team ID, which is great. I already picked that one up. Issue date and expirations. We've already got our Unix times, so that's good because issue date and expiration are both going to be our Unix epoch times. These are going to be strings, ultimately. let's see here. Come get this over here. Okay. So we've got our issue that. We've got toString this guy here. We'll go ahead and toString this one because these are all going to be, okay. Still doesn't like something. That's okay. We'll come back. String, team ID. Cannot convert from string to, oh, that's right. Of course we need claims. This isn't a dictionary of strings. This is a bunch of claims. I guess we could get kind of fancy and we could link this thing. Let's see. Select. Oh yeah, there you go. X into new claim, system security claim, and then X key, X value to, oh my God. It's like the link Olympics. There's a buddy of mine I used to work with, and that's what he would call them, and he would go and write the most convoluted, ridiculous link queries I've ever seen. It was actually a lot of fun to watch, but of course we certainly don't need to do this. This is kind of, this has, Q circus music qualities. So let's just do a new array of claim. And we will use system.security.claims here. We can get rid of our hello world, I guess. Probably don't need that anymore. Okay. And our new claim. And then, of course, in here we have to do new claims instead. It is a little, I don't know. It is a little verbose. I'm actually really curious. What would the, I wonder what the compiler would do with this select down here. Like, I wonder if it would just, would it be clever enough to see the circus, or would it ignore the circus? I don't know. That's probably worth exploring one day. Maybe I'll do that tomorrow. This is the value of being unemployed, is you can do silly stuff that people may or may not find valuable. Okay. So we have our array of claims and our payload. Now the ones we need issuer, which are team ID, we need our issued at, we need our expiration, and then our last one we need is our subject claim. And our subject claim is going to be just our service ID. There we go. Bam. Don't need that comment, but thank you for the attempt. Thanks for the help here, Copilot. Okay, so there's our payload. Cool. And then the last part that we need is we actually need to create the JWT security token, right? So look at this. It's already there. So we're going to create a new JWT security token with our header and with our payload, okay? And from here, we then need to, so we have our security token. We need to go and write it, which means we need the handler. Thank you again. So handler, write token, and we'll have to, of course, we'll have to write this into something. And we'll just call this Apple token. And for the moment, let's just go print this thing out and see what we get. Okay, so we have our header. So first we're importing our key, right? So we're getting our key here. We are getting our, wait a minute. Is it NIST P256? Okay, I don't. I'll have to go back and look. I'll have to go back and check that one. I'm not entirely certain that's correct, but. So we have our cred, we have our signing credentials, which I wonder if the signing credentials, does it really actually need to know the algorithm here? Would it not? Well, whatever. Okay. So we got our key ID, we've got our ID in here. Those are correct. We have our issuer, we have our subject. And the algorithm will be added by, the algorithm key will be added automatically. What is this thing complaining about? Have I already done everything? I guess I have closed everything I needed to close. Yeah. Okay. So I guess for the moment, well, let's just go run this and see what we get. Let's not type there, but rather down in here. So let me clear this .NET. Let's do .NET run. Okay. And okay, so it failed. We have a comma somewhere. Oh, here at the end. Of course. It's always something silly like that. Okay. Now we have a JWT, which is a good start. Let's just do a curl from here. In fact, let's set, I did this earlier to make sure it would work. Let's just set this, oops. So I'm going to set this thing here, Apple token. All right. So if we do that, we should get it. Okay, so we got the same one that we just put in, which is great. So let's do a curl. And so we're going to use bearer, right? So we're just going to, our authorization is just a bearer token, but we're going to use that Apple token. And then I've got my home lat, home lawn, and some things. Let's see if this works. Invalid signature. Okay, so the signature is wrong, which means I think I messed this up. I think I picked the wrong one of these. Let me check. So I don't think, because we're not going to be creating a new key, I think all we need to do is just create this. I don't think we actually need to give it an algorithm. So let's .NET run this thing again. And we get a new token, most likely. Okay, so what we'll do here is I'll just do Apple token equals .NET run. We'll see if that works. Then I'll have to do it again, get a new token. Looks like we did get a new one. So let's go do a curl on this, and still get an invalid signature. That's weird, I don't know why. Okay, so what is wrong with the signature? Let's go. Okay, hang on, let me check. So we've got so we're reading from our file, right? I wonder if should be reading from that file, right? Read all text, right? Okay, so we're getting it from our PIM file. Okay, the new ECDSA security key with our creds, right? We're using ECDSA SHA-256, right? Which is what we should be using. Oh, that looks good. Dictionary of claims for the header is good. We got our key ID, team and service ID. Okay. Let's go look in this token first and make sure that there isn't something obviously wrong with this token data here. Let's go take a look. So I cannot paste in here. Okay. Oh, did I not sign it? Yeah. So we got our algorithm. We've got our type. I don't need a type. Where's my key ID? So we have our key ID, and we've got our ID. Those don't seem to be in the header. Okay. All these look correct, so that's good. So our subject's correct. So our payload, we know our payload's good, but why is our algorithm broken, or our header broken? So here's our JWT header. We've got our signing credentials. Okay. Is this file missing or something? Or did I misname the file? Like, let's see. Nope, .p8. Okay, so that all looks good. Team ID, key ID, all that's correct. We're creating our ECDSA that we can use with this PIM, and this is a security key, so it's all good. That all looks the way I would expect it to be. Okay. So what does it not like? So we got signing credentials, and then we've got, that's the outbound algorithm map. We don't actually need that one. So that would be why we need to put this additional header claims, but I think what we can do instead is we can just include it. We don't actually need a dictionary here. We just need that. Okay, so this is still a dictionary course. Okay, so now we have, instead we can initialize the signing, or we can initialize the header. We initialize the signing key here, or sorry, we initialize the header, and then the header initialization would be, so this would really be similar to saying header dot, I guess we were to add if we were to add these to the header. So yeah, with header parameters, and these are our actual parameters. Don't need that there. And then these are the actual extra bits of data that we want put in there. Okay, let's run this again. Let's see. Oh, excuse me, goodness. So we got our Apple token. Now we have a not found, so that's great. That at least means we made it a little bit further. My guess is that perhaps my home, this must be a different thing. So my home lat long is not there. Let me go grab a lat long. But it looks like we have it. So 42,860 and 82,590. Let's just do that here quickly. Home. Oh no, it's already there. Home lat. Excuse me, I'm still getting over something from a while back. All right, so we run that, bam, good. Now we get our weather. So this is great. So now we've successfully converted from our DarkSky API over to WeatherKit. Now it's kind of a circus. I'm not going to lie. This seems like a significant amount of work to get the weather. But anything that's worth doing is worth overdoing, right? So my thought now is, so we've got a way that we can generate this, but I've got this secret key, right? We've got this key that we have to deal with. And I'm not entirely sure the best way for us to manage this key, because obviously we don't want to, schlep it around everywhere. Can't ship it anywhere, of course. Which makes me wonder if perhaps, of course, on the server side, anything server side, we can generally say it's something that we can protect, right? If it's infrastructure that we control, we could of course use something like a key vault or one of those type things. But then we have the question of, okay, cool, I'm going to go generate JWTs from this endpoint, but how do we authenticate to that endpoint? Do we use just something basic? Do we do something different? I swear, ever since we got sick the last time, it feels like I can't shake stuff. It's really annoying. So if we were to put this into something like an Azure function, we call that endpoint, we'd have static keys. So maybe that's ultimately what we end up with, is we started with a static API key. We create new infrastructure to go and generate these things, go generate these tokens, and then we protect those behind a static API key. Actually, maybe that's what we should just build that, is we should just build the WeatherKit proxy. Although then you would have to, well, I mean, you could probably do something like that. It might be kind of cool. So you would give us the private key. What could go wrong? And if you give us the private key, and give us your existing, maybe you give us your existing API key for DarkSky, right? You could kind of essentially proxy them back and make it multi-tenant. And I think that'd actually be kind of cool, especially for legacy stuff. If it's something you just need, you need to buy some time, that might actually be an interesting way to do it, where we go and build us a little Lambda, a little function, and the function is going to handle returning some credentials. Or maybe it just goes and fetches the weather for you. I'm not entirely certain. You just proxy the whole thing. And you have an allow list of your known key IDs, right? Or your known API keys. It's kind of silly, but I think it would work. Anyway, so at least at this point, we got a way that we can go get a token. And it's fairly straightforward. .NET makes this pretty easy, I think. The other thing I'm curious about is if the other JWT library actually makes this any easier. So let's create a new class. I'll call this one JWT net token generator. And we could probably make the, hello. Huh. Boy, that looks like a whole lot of stuff there. Anyway, so let's go and add the package. And I think it was, this was, oh, it's just JWT. Okay. Buckle up. Let's go. All right. JWT. This one has more likes than the Microsoft one. So if you don't have to use the Microsoft one, then, you know, more power to you. Okay. So now we got our JWT token generator. Let's go create this class. Oh my goodness. So I don't know how to use this library, so we're going to have to go look. Documentation. Project. Okay. Let's go look here. Get this zoomed in. All right. So what we want to do is create and encode a token. Okay. We want to assign it to. So we have, okay, so they've got a Fluent API, which is kind of cool. These were super popular for a while, but I haven't seen them a whole lot recently. I don't know why that is. So here's our payload, okay. So, okay, that all looks like pretty straightforward, I guess. How much control do we have over things like the header? This is token validation, okay. Let's take a look. I'm just going to take this out as is. And let's go see. I'm just going to we'll just make a little static here. We'll make this whole class static. Generate token, and we'll pass it in some stuff, whatever. So, and here, well, I guess we'll need to use, we've got a bunch of usings we're going to need. Okay, and then what is this one? JWT algorithms. Now we don't need RS-256. We're actually use a different one. What is this serializer? So this is okay, so okay. And then the encoder here is a JWT encoder. Now we don't want these to get confused, so we might have to go and we'll have to go do a thing here. But so this is our payload. And this is encoding the payload, but is this actually doing any signing of the certificates? Or is JWT, or is this only doing encoding of them? Why would it have an algorithm with a certificate, though, if it wasn't going to include that? So, all right, is there anywhere we can, oh Lord, we don't have to get rid of custom serializer. Where do we modify? Okay, this is ASP.NET Core, which we're not using. Okay. So, in here, it's unclear to me if this is actually going to go do signatures. I'm assuming it does. I feel like it would almost have to, but it does. It is very specific in the language that it's encoding. I don't know. Let's go see what it, I guess we're going to see what it puts out. So, let's see. Does it have our 256? It does. And then what is this expecting? It's expecting our public key and private key. So let's go get this. Let's go get our key from here. We'll just take our key with us. Although, you know what we could do? We'll just give it a key. How about that? Security key. Okay. I believe they all derive from security keys, so that should be no big deal. Key. What is this expecting? Oh no, this one's an ECDSA. Okay, so we'll just give it the algorithm only. No, it wants just the algorithm wrapper. Okay. 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 So that presumably is going to go create our key for us. We have our JSON-net serializer. No idea what that's going to do. Our base64 URL encoder, which presumably is going to go and URL encode all these, or base64 URL encode our different components. And then we have our JWT encoder. Now, what overrides do we have here? We have the algorithm. We have our serializer, and we have our URL encoder. And then why is this blowing up? Why is it like this? No argument given that corresponds to payload of encode an object, and a byte array. What? Hold up. Extra headers. Okay, so good. So this is where we can put our headers in. It's actually great to know. So in fact, let's go ahead and put our headers in here. Maybe we should create these somewhere else. So this is our payload. We'll just create a new thing here, a new dictionary of string object. Yeah. Okay. I'll just go grab them from here. I feel like there's lots of duplication, but that's okay. We can always come back and fix that later. Or we could take this part out and that's just going to make it messy. Let's not worry about refactoring all that right now. Although I don't have any of my constants. I have to send all that stuff over too. Blah. That's okay. I want to make these kind of isolated from each other because I want to see just how much sort of difference there is in these implementations. So, can I make this? No, I can't do that, can I? Can't be marked static, of course. Let's just make this whole class static. Okay. What's the problem? Let's have return type. Oh, yeah. Let's just return a string for the moment. Let's do it like that. What's the problem? Oh, yeah. Okay, fine. Okay, so we got our headers fine. Our payload is pretty easy here. We've got our claims. Looks like whereas this takes a whole set of claims, this one is going to take just the same dictionary, which is fine, I suppose. Yeah, we can't do that. So now I remember an old friend taught me once a very cool way. Oops. So you can select multiple lines at a time on here, which I think is kind of cool. Oh my God, what on earth did she buy? Goodness gracious. Okay. So in here, I don't remember, was it Shift? Was it Shift, Alt? No, Shift. No, I don't remember what it was. It doesn't really matter. So we'll just do it's not going to be a new claim. It's just going to be a dictionary of string and object, which, if we're being honest, probably can just be string, but whatever. Okay. I really wish I could remember that thing now because I always thought it was pretty cool. You could select multiple lines and then it made stuff like this a whole lot easier. I have this new keyboard. I guess it's not that new anymore, and I love it because it's very nice to use, but it's like some of the keys that I'm really familiar with on Windows, I'm having a hard time sort of remapping over to Mac, and it's making it somewhat difficult. Anyway, okay, so we got our payload here. Payload's looking good. So now our encoder, instead of having to do all this goofy stuff here, we'll just do our header. Additional headers. We have our payload. Okay, so we got our payload, and then the key bytes used to sign the token. So that must be our key, but it doesn't want a security key. It wants bytes or a string. So can we get our bytes from here? No. Can we export the key? I guess we're going to have to. Export the key to a byte array. All right. Easy enough. What doesn't it like here? Not all paths return a value. Of course they don't. That's right. Of course, it doesn't need to. Let's just void this out. I don't think there's anything async happening in here anyway. Okay, so we're creating our header. Pretty straightforward, nothing fancy here. We are creating our payload. Again, nothing fancy. Has all the bits in it that we need. I am assuming and hoping that this will inject our algorithm and our algorithm header. We got our key ID. We've got our ID. So let's go call this from another thing. Declare types and namespaces. Oh my goodness. Okay. All right. We don't need anything from system identity model tokens. Cool. So over here, instead, let's do a JWT net token generator, generate token with our certificate, and let's write this out. And then we can write the other one too, I suppose. Oh no, this is going to write it anyway. So good old, this is terrible. Okay, so our first one will be our JWT net one. Our second one will be our Apple one. Let's see. First, let's see if it builds, and then we'll run it and let's see what we get. Presumably, they should at least have the same data in them. Can't sign data without the private key. Well, we have the private key, however. So let's go back and look. So we're exporting the private key. Yeah. So there's our private key, which is what we need to sign. And we're doing this, yeah, so cert cred, so we're importing from a PIM, so we have our PIM, so the certificate cred should have our PIM, and that's what we're sending over, so it should have the private key data in it, right? Where was this? So this was at certificate algorithm sign, which was at line 30. This is when we're trying to sign it. Okay, so I don't think it's a PKCS private key, but then again, I'm not a cryptography expert, so yeah, so it can't sign data without the private key, but we literally have the private key. So what does it not like about this, I wonder? And where is the try export? No, I won't be able to export it either. I mean, are we saying there are no bytes there? I guess it's worth looking. I guess it's worth looking to see. So we could do export our private key here. And then this will just be our P key, our private key. All right. Oh, wait a minute. Oh no, that's our key. Yeah, our key. All right, that's our key. Everything looks good there. All right. Yeah, P key's a private key. Yeah, thanks Copilot for that one. Appreciate that. So are we saying this doesn't actually have any data in it? Let's take a look at how big it is. Maybe it's empty. Or maybe it's one of these things, once you read the stream, you got to turn around and go move it back to position 0 in order for it to be there. Yeah, it's 121 bytes. Seems like a sufficient size for what it is. Seems like a reasonable size. So what is this? This gives me a byte array. Yeah, I mean, it's a byte array. It's not a stream, so I don't need to have a position in it. So why does it like this? I don't understand it. I don't know what a PKC is. I'm not sure the difference between the two, so I'd have to go back and look. So, yeah, so, okay, so there isn't one there. Okay, or maybe it's in the wrong format. I suppose that's possible. It's 138. Okay, so for whatever reason, we're importing this key to this algorithm, but we have the key and then the bytes to sign. Can't sign data without private key. That's so strange. Am I doing this wrong? Okay. The key bytes used to sign the token. Seems correct from here. So we have our extra headers, right? That's our header. We have our payload, and we have our byte array of our key. So what's the beef? Create a JWT given a payload, the signing key, and the algorithm used. Yeah, I mean, it's not. I suppose the other. Well, let's go read. I guess we'll just read all the text. Let's just give it to it as a string and see how it treats that. Worth a shot, nothing else. Yeah, still says there's one there. Can't sign without private key. What am I missing? What am I missing about this? I feel. Oh. So ES256 wants a public key, but let's see here. Now, Apple says, and I'm not entirely certain of this. If I only give it a key, if I only give it one, is it nullable? I guess it can be. So I guess I can provide no public key. Let's run this again. Yeah, public key can't be null. Now, if we look at Apple's docs say because even if we look in the file, certainly we don't have a public key in there. Create a WeatherKit identifier and a private key so you can use a developer token to authenticate yourself. So I wonder, I mean, the whole point of PKI is you can sign privately, verify publicly, right? And I guess, I mean, the way this reads, it's as if they somehow either, it's almost as if they like derive, no, they couldn't, I don't know. Well, the net of it, though, seems to be that in the absence of a public key, which I guess I could go look, like Apple developer key, public key, like maybe it's available somewhere. This is for sign-in with Apple. I can't imagine. Yeah, because this is us issuing them, not the Apple ones. I don't think that's gonna be correct. I don't know. I guess this will give me something interesting to go look into this afternoon because I don't understand how. Yeah, because like we aren't signing with these keys. These are the keys they're signing outbound identity things with, like identity tokens. So how do we get our public key? Or is it somewhere in here and I'm just missing it because I don't use this much? Like, what's the scoop here? So we'll go over to keys, right? Here's my key. It has a key ID. Yeah, I don't know how. I mean, does Apple hold a public key? That doesn't make any sense to me. I don't know. Well, if I know any Apple people, hit me up. Because I'm curious how this works. Because I don't know how, I just don't understand how it would work unless you have the private key or unless you have the public key. I mean, I guess conversely, you could also have the private key and you could be signing it and I don't know. It doesn't make any sense. It doesn't make any sense. I don't know. I mean, I don't know. It's very strange to me. Generate the web token. There's nothing really in here about subject public claim key. Yep, so that's just our... I don't know where the public key is. It has a key ID. I wonder if I gave it a key ID. If I gave it a key ID, would I be able to get the public key for it? I don't know what the endpoint would be. Let's see. Like, this is all sign-in stuff. We don't need to sign in. This isn't sign-in stuff. Because we're sort of like the inverse. In the sign-in with Apple case, Apple is signing a token attesting to who we are. I don't know, Callaway. That's a good question, Mr. Corey Cal. That's the part I don't get, right? Is like, Apple is signing tokens outbound. That's why they have to publish this, right? So they publish their key set. I am signing with the certificate that they gave me, admittedly, but I am signing the cert. I am signing the JWT and sending it back. And that's the part that doesn't. That's the part that doesn't make sense. Is generally you get a key pair. What am I missing? I feel like I'm missing something, but at any rate, if this thing needs a public key, I don't have a public key to give it. Right? Like, I don't know where it would be for this specific for this specific thing, right? Because here's the key. I mean, I have a key ID, which I guess maybe in theory I could say, oh, I could go and, here, I'll give it this. But it's going to want to need, it wants to need ECDSA key anyway. It's not going to take a string. I mean, In the absence of a public key, what do we give it? And that's just what I'm just not sure. Now, at the same time, I've got the private key. What would it actually need it for? Let's do, I guess I'll create one. I'll create a public key. I'll create an ECDSA here. Okay. Oh, okay. So here's the token that's generated from that, from the second one, right? So if we take this over here, go take a look at it. Still can't paste in here for whatever reason. This all looks correct. And in theory, we'd be able to make that call, no problem, right? It's got everything we need. Got the algorithm. It's got the ID correctly. It's got the kid. It's got the subject. The times are wrong and bad. Invalidate, it says. Oh, because these are strings. We don't need string dates and times. We need not to string these, in fact, because these are numbers, not strings. Okay. So that is one thing we should go and take a look at first. Run this again. The top one is the first one, of course. So let's go grab this. Take a look one more time. Still can't Command V in there. And now our times are correct, 12:30, 13:30, so they're an hour apart, as we'd expect. So this is a good token. So yeah, I don't know. I don't know why there's something about this, but at the end of the day, I think both of these implementations seem pretty easy to use, right? Like nothing about either one of these is particularly seems particularly difficult. This one is a little bit more generically based. Lots of interfaces for our algorithm, serializer, encoder, but we are getting a signed token. Looks okay. I don't understand why it needs a public key if it's signing with the private key, because we're telling it what key to sign with. So I don't understand that part. But that might just be, I don't know. It's going to bug me. I'm going to have to go figure it out. And it could also be an Apple thing, if Apple just being like, well, we're not going to give you your public key. So, go fly a kite, for lack of a better term. I don't know. Anyway, okay, so I'm going to get out of here. We're going to go find somebody to raid or whatever. I think it's kind of cool, but sometime the next few days, I got to figure out a schedule, and I got a bunch of other stuff to figure out. One of the things I'm thinking about, though, is let's take this and let's just go wrap it in we'll go wrap this in a, we'll go wrap it in a function, which the cool thing about a function is we can run a function in a container locally. It's kind of neat. We run on a Raspberry Pi even. I used to have one that controlled the hue lights in my house. For whenever I was in a meeting, it would sync up to my Teams presence. So that might be good for next, because that way we can run it in Azure if we wanted to. Of course, we'll have to put protection and all that sort of stuff around it. We'll have to figure out a way to authenticate it if it's on the public internet. But conversely, if it's running locally on a container and you trust your local network, I mean, you could run it on a Synology, you could run it on a Raspberry Pi, run it on anything. So I think we should go do that next time around. I think it'd be kind of cool. Be kind of fun. Yeah, so I don't know. You tell me what you think. I'm going to start trying to stream a little bit more, at least. If for no other reason than, it's a way to enjoy a little bit of time off before going back and getting back into the grind, So anyway, before I go, let's put this. Before I go, we can put this up in I'm not going to put this in GitHub. I'm going to stick with .NET. I'm going to stick with the .NET implementation. I don't really care about this one. Like, it seems to work well. It's cool if you want to use it. That's awesome. I'm going to stick with the .NET one because it's already there and I know that it works. And I think generally, if you look at these two chunks of code, I mean, JWT payload could take. I'm pretty sure it takes a dictionary of strings too, or a dictionary of string object. So. I think that one will be fine too. So I'm probably going to stick with this one for now. But at any rate, it was fun. Thank you. And now we've got our weather API. So next time around, we're going to figure out how we're going to host this thing in a way that we can access either locally or through a secured external API. And maybe we can figure out a way to do like Apple ID sign in from a local machine. I don't know. I guess all that stuff. Anyway. I guess I'll have to figure that one out next time. So let's go find somebody to raid. Is anybody even live? See, that's the problem. I'm using my own account, and my own account has like nothing on it. So I'm not entirely certain who is even live right now to go raid. But that's okay. Come back. I'll be back in a few days, and we'll work a little bit more on this. And thanks for hanging out with me today. And we'll be back soon. Keep it up on Twitch or YouTube or LinkedIn or like all the different places, and we'll see you on the other side. So thanks for hanging out. You find me on Twitter and all that stuff. Oh wait, I think I have a screen that has my Twitter names on it. Find me on Twitter and YouTube, and I'll get my GitHub and stuff up there later on today. If you have any tips on creating like branding and stuff for streams, let me know. I found this one on the internet. It looked cool, but the purple and green might be a little bit played out. But anyway, thanks for hanging out with me today, and I will be back. I'll be back later. See ya.